Jai Hind. In this lecture, I am going to discuss line coding schemes. First of all, introduction about me. Myself, Dr. Sunil Kumar, working as a professor in IT department. So today, we are going to discuss different line coding schemes. Now, first of all, what is line coding? Basically, line coding is the process of converting the binary data. Binary data means 0 and 1 into the digital signal. We can take the example. For example, we have this binary data in terms of 0 and 1, and after applying the line coding scheme, it will be converted into the digital signal like this. For example, 0, that is on the baseline, then 1, it will be up, and again 0 and something like that. We can broadly divide the line coding schemes into 3 categories. First one is called unipolar, second one is called polar, and third one is called bipolar. The second category can be further divided into further 4 categories. The first one is called NRZ. NRZ means non-return to 0. Second one is called RZ, that is return to 0. Third one is called Manchester encoding. Manchester encoding. And the fourth one is, that is called differential Manchester encoding. NRZ can be further divided into 2 categories. The first one is called NRZ, that is L means label, and the second category is called NRZI. I means inverted. So we will discuss each line coding scheme like unipolar, NRZL, NRZI, RZ, Manchester encoding, differential Manchester encoding, and bipolar with the help of example. In case of unipolar encoding scheme, we use only one voltage level to convert a binary data into digital signal. Let us take an example. For example, we are converting this digital data into digital signal, that is 0, 1, 0, 0, 1, 1, 1, 0. Now, in this case, what we are doing, 1 we will code as a positive voltage and 0 will be coded as a negative voltage. And after converting, it will be like this. Now, how we are getting this? This is called the baseline. This is called baseline, and these are the vertical lines. Now, in case of 0, that is for negative voltage, we will simply put the line onto the baseline. If it is 1, then definitely we will do it like this. For 0, onto the baseline, for 0 onto the baseline, for 1 it will be here, for 1 it will be here, for 1 it will be here, and for 0 it will be here. And finally, we have to connect these vertical lines. This is the conversion of binary data into the digital signal by using unipolar encoding, where we are using only one voltage level. In case of polar encoding, we are using 2 voltage levels, one for the positive and another for the negative. Let us take an example. As we have discussed earlier, NRZ, and you can take RZ, Manchester encoding, and differential Manchester encoding come under this category, that is called polar. And NRZ further divided into 2 categories, that is first one is the NRZL. L means level. NRZ means non-return to 0. Now, in this coding scheme, the level of the signal is dependent upon the state of the bit. How it is? Let us take an example. Now, after applying this NRZL, it will be like this. Now, how we are getting this? In this case, we will take 0 will be treated as a hero. What is the meaning of this? I will tell you. And 1 we will take as a 0. Now, because 0 means that is hero, so that means hero means upper side. So that is 0. I am taking is at as upper side. 1 that means 0, that means the bottom side. Bottom side below the baseline. Again, that is 0. This, because we are treating as a hero, then again 0. For 1, it will be the below the baseline. For 1, that is also below the baseline, same. And for 0, we are treating as a hero. That means 0 will be above the baseline and 1 will be the below the baseline. That is baseline. Now, again we have to we have to connect these lines that are the vertical lines. And finally, this digital data is converted into the digital signal by using this NRZ, that is non-return to 0, L means level. Now come to the second category of NRZL, NRZI, that is non-return to 0 and I means inverted. What is the meaning of inverted? Whenever 1 will be encountered, the signal will be inverted. Let us take the example. Now, how we are getting this? First of all, in this case, because we are taking 0 as a hero, and the previous case, now we have taken above the baseline, that is our baseline. Then whenever 1 will be counted, it will be inverted. Now, second one bit is 1, then it will be inverted. That means if it is in the upper side, it will come to the bottom side. If the signal traveling at the bottom side, it will come up to the upper side. Now, at this time, it is here, then it will be inverted. And it will be like this. Now, in case of 0, it will continue. If it is upper, then it will continue in the upper above the baseline. If it is the below, then it will continue as it is. No change. Again 0. Whenever 1 will come, it will be inverted. Now, this time we are at the bottom side. Then we will invert the signal. Then we will come up the upper side. Then again like this. Again we are getting 1. Again the signal will be inverted. Then it will come to the bottom side. Again 1 is encountered. Again signal will be inverted. Now we are getting 0. In case of 0, simply we have to move on the signal. Either we are at the top side or we are the bottom side. So this is the way how to convert a digital data into digital signal by using NRZI, that is non-return to 0 and I means inverted. That means signal will be inverted whenever 1 is encountered. So next encoding scheme is called RZ. RZ means return to 0. Now, in this case, we are using 3 values, 1 for positive, 1 for 0 and 1 for negative. Let us take an example. Now, in this case, what we are trying to do, for 0, we will use this Z. That's we are can say ulta Z we will take. For 1, we will take simply Z. And here, for example, first of all, 0 is encountered. Then in that case, because we have to do this like this, then it will be like this. Now 1 is encountered. For 1, we have to simply take from, that is from 1 to 0 like this. That is from 0 to 1. That way we have to take from upper side, then it will be like this. For 0, again we have to take from the bottom side, then we have to come here. Again 0, then we have to take from the bottom side, it will be like this. Now 1 is encountered, and count 1 means from top to down, that is like this. For 1, again, first of all we will go here and from top to down. Again 1, as we have discussed, 1 means from up to down, it will be like this. For 0, from bottom to, from baseline to this. Okay, my mistake that I've done some mistake. I'm correcting this. This is not the case. In case of 0, we have to start from 0 to 1. That means first of all we will come down here. I'm changing, that is like this. So this is the way how to converting a digital data into digital signal by using RZ encoding. Again, I am repeating, for 0, we are using from 0 to 1. That means below the baseline, we have to start and we have to draw like this. For 1, we have to start above the baseline from like a Z. And in that way, the digital data will be converted into the digital signal by using RZ encoding scheme. Now the next scheme is that is called Manchester encoding. In Manchester encoding, the transition at the middle, that means now we are putting the transition in the previous scheme at the vertical lines, but here we will put at the middle of the bit. That is used for synchronization and for bit representation. Let us take the example. It will be like this after drawing this. Now in this case, we have just reversed. For 0, we will take like this, and for 1, we will take like this. That means you can say simply in a Hindi language, that is Ulta Z, and that is simple Z. Now first bit, that is 0, that means, and transition in the middle. So this will be like this. That is for 0. Now 1 means from bottom to top, that is like this. Again 0 means this. 0 again we have to start from the top. That means we have to, first of all, we have to go here and then we will draw like this. Again 1 means from this side to this side. Again 1. So first of all, I have to come this side and it will be drawn like this. Again 1. Then first of all, I will come here and then will be drawn like this. Now next bit is 0. For 0, we have to start from upper to lower. This is the way how to convert a digital data into digital signal by using Manchester encoding, that is used for synchronization and bit level representation. Again, I'm repeating. 0 means we are starting from 1 to 0. 1 means from 0 to 1. And finally, you will get this. The next scheme is differential Manchester encoding. In this scheme, what we are, again we are using the transition at the middle of the bit, okay, and that is only used for the synchronization. The bit representation is defined by the inverse, or you can say non-inversion at the beginning of the bit. How it is? Let us take the example. Now already we know if we are representing 0, that can be this Z or that can be this Z. That means simply we are making a Z, or you can say this one. For 1, that is also same thing. It will be like this and this. Now what we have added in this case, in case of 0, we will put here on the vertical lines, we will start like this. If we are simply Z, then it will be like this, and it will be, if we are starting from bottom, then it will be like this. We should keep in mind these things. Now, for example, first bit is 0. Now, in case of 0, we will start from, for example, we are starting from this, that is like this. Transition at the middle. Now for 1, now in this case, if we are at the above the baseline, then simply start from there. That means now here we are here, then we will take this one, that is this one. But in case of 0, now 0, for example, we have to draw for 0 bit. In this case, first of all, we will draw this. That means we are using this one, and sorry, this one, and we will draw like this. Okay. Again 0. Now we are at the bottom side of the baseline. Then in this case, we will draw this, and we will be drawn like this. 1. Now we have to continue. For this, it will be like this. For 1, it will be like this. For 1, it will be. That means if we are at the top side, then we will start from there. If we are at the bottom side, then we will start from there. Now again 0 encountered. Now in this case, first of all, we will draw the vertical line. Now we are at the bottom side. For the bottom side, we can use this, that is this one, second one, and in that way we will convert a digital data into the digital signal. Again I am repeating, always we are representing 0 as a simple Z, or you can say this kind of Z, that is called ultra Z, and same thing for 1, that is this or this. Now what add-on we have done? In case of 0, we will start from the vertical line. If we are using this, then definitely we are putting here this, and if we are starting this, then we are, according to the bit encountered, we will use 0, either this one or this one. In case of 1, if we are at the top side, or you can at the top above the baseline, then we will use this Z. If we are at the bottom, then we will use this Z. In that way, this digital data will be converted into digital signal by using differential Manchester encoding. And these are very important topic, always comes in the exams. Next category is called bipolar encoding. In this case, we are using 3 levels. One level for the positive, one level for the 0, and another level for the negative. Let us take an example. Now in this case, because 1 is used for both levels, then first of all 0, then that means you are drawing onto the baseline. Now 1 is encountered, then because 1 used for the up and for positive negative, then first of all we are using for the positive voltage, then we are this, again 0 on the baseline, again 0 on the baseline. Now when second times, or you can say next time 1 will be encountered, then if it is for the positive, then it will be inverted. That means we will use the for the negative. Now this one, for this one we will below the baseline like this. Again 1 is encountered, that means again it will be used for 1. If we are using for negative, then it will be used for positive, that means it will be changed like this. Again 1 is encountered, again we will change like this, 0, that means onto the baseline. That means this one for the positive, this one for the, for example, negative, again positive, again negative, and like this, because we are using 3 voltage levels. Okay, one for positive and negative also, and 0 for the baselines. In that way we can convert any digital data into the digital signal by using bipolar encoding scheme. Hopefully now you can differentiate between these categories. Again I am repeating, line coding we are using for converting a digital data into the digital signal, and in a broad way we are dividing into 3 categories. One is unipolar, one is polar, and third one is bipolar. The second category is further divided into the 4 categories. One is NRZ, then RZ, Manchester encoding, and differential Manchester encoding. NRZ further divided into the 2 categories, that is NRZL. L means level, NRZ means non-return to 0. Second category is NRZI, in which we are inverting the signal whenever 1 is encountered, that is NRZI, and further is Manchester encoding and differential Manchester encoding. Thank you.